everyone and welcome to the second video of real numbers. Today we will learn what is the meaning of prime factorization, how to find prime factors, and what is the application of finding prime factorization. So let's start with the first thing, prime factorization. Prime factorization is a method in which we find the multiples or prime factors of a given number. So what do you mean by prime? A prime number is a number which has only two factors, the one and the number itself. That is prime factorization. So how to find, after finding out the prime factorization, where it will help you out. So by prime factorization, we can find the LCM as well as HCF of more than two numbers. So when we talk about LCM, it means lowest common multiple. It has only two steps basically. First, you find the prime factorization of each number, then you write it as a form of products of prime, right? And after that, you calculate the highest power of the factors to get the LCM. Okay, highest power of each factor, not a common factor, each factor. Okay, now let's talk about highest common factor. This is a multiple, right? How highest common factor, again, you first step remains the same. You just have to find the prime factors of each given number, then you have to identify the common prime factors, and then once we have identified the common prime factors, then we will multiply the common factors. That is, the product of these common factors is known as HCF. Let me show you this by an example. Before moving on to the exercise, you should know what is the fundamental theorem of arithmetic. Fundamental theorem of arithmetic means every composite number. Now, what do you mean by a composite number? A number which has more than two factors, right? So every composite number can be expressed as or can be factorized as product of primes, and this factorization is unique apart from the order in which the prime factor occurs. What do you mean by that? Suppose I have to find the factors of 2, 0, 2, 1, 0. So first of all, let me show you how to find the factors. 2, 1, 0, सबसे पहले वो 2 से divide होता है. So 2 1s are 2, right? 2 0, 2 5s are 10. After that, it gets divided by 3. So 3 3s are 9 and 3 5s are 15. After that, again, it gets divided by 5. 5 7s are 35, and after that 7 1s are. So I can write the factors in the form of 2 3 5 in 2 into 3 into 5 into 7, all prime factors, right? Or the order will not matter. I can change the order, right? 3 into 5 into 7 into 2, right? Or any other way. So this is what is basically prime factorization theorem, right? Fundamental theorem of arithmetic, that every composite number can be expressed as the product of primes and the order of factors will not matter. It will be for one particular composite number, it will be a unique factorization. Okay, let's move further and let's start with the exercise. Let's talk about exercise 1.4. So question number 1. Again, I told you the method remains the same. आप सिर्फ 140 के factors find करोगे. So 2 पे, right? 2 7s are 14, 0, again 2, 2 3s are 6, 2 5s are, and then 5, and then 7. So how can you express 140 as? Can I write it as 2 to the power 2 into 5 into 7? Obviously into 1 तो हमेशा आता ही है. So these are the product of, this is how you do prime factorization. Let me do it for a bigger number if you want to do it. Okay, so you can do it. All these can be done in the same way. 156 in the same order, right? And this is how you will get the prime factorization. So if you want to do 156 in the same way, divided by 2, 2 7s are 14, right? Again 1 6, 2 8s are 16, again 2, So 2 3s are 6, 2 9s are, so this will go on 3, 3 1s are, 3 3s are, and then 13. So how will you express 156 as product of primes? 2 to the power 2 into 3 into 13 into 1, obviously. Right? Similarly, you can do it for all the parts. Let's do question number 2. After prime factorization, let's just check what are we getting, that this LCM into HCF will be equal to the product of primes. Let's a product of the two numbers. Let's check. Suppose I want to do the first question. 26 and 91 are two numbers. Let's find out the factors first. 26, so 2 1s are, 2 3s are, so this is 2 into 13, children. Obviously into 1 is always there. Similarly 91, let's do for 91, you know the factors. 7, 7 1s are 7, right? So 21, 7 3s are, so this is 7 into 13. So now let's just check what is the LCM, HCF as well as LCM. First let's find out HCF. So you know HCF का मतलब क्या होता है? हाईएस्ट कॉमन फैक्टर. तो चेक करो, हाईएस्ट कॉमन फैक्टर तो आपको दिख ही रहा है, ऑब्वियसली इंटू 1 तो दोनों में ही आएगा. सो दिस इज 13 into 1. So HCF is 13. Now LCM is lowest common multiple. Let's write down. So 2 into 7 into 13 into 1. Each you have to write each and every distinct factor, right? So 2 7 13 1, so that is your LCM. So you, if you multiply, you will get this as 182. This is 13. So let's check, are we getting, let's find out HCF into LCM. That is 13 into 182. So check, 13 into 182 is 2366. So let's just check. Are we getting 26 into 91 also same thing? Yes, we are. So from this we can say that HCF into LCM of two numbers AB will be equal to product of the numbers. So this is a fact which I want you children to remember. For two numbers, this will be valid. Okay, children. Let me do one more question so that the concept is clear, much more clearer. Let's do the second part. No, let's do the third part in that case. 336 and 154. First of all, I want you to find the prime factors. Sorry, it is only 54. So with 336, the prime factors is 2 to the power 4 into 3 into 7 into 1. And factors of 54 is 2 into 3 to the power 3 into 1. These are the prime factors of the respective two numbers. Let's talk about HCF. So common आपको दिख ही रहा है, right? So HCF of this is, which is common. So obviously 2 to the power 1 is common, right? And into 3 to the power 1 is common. यहाँ पे दो, एक 2 to the power 1 है, यहाँ 2 to the power 4 है, लेकिन जो common है बेटा वो तो least वाला ही होगा. So that is why 2 to the power 1 is common. Similarly इसमें 3 और 3 दोनों common है, लेकिन यहाँ 3 to the power 1 है. Again जो common है वो 3 की power 1 है. So that means HCF is 6. Let's talk about LCM. LCM का मतलब क्या होता है कि आपको सारे फैक्टर्स पहले लिखने हैं, 2 3 7 and 1, all factors with its highest power, lowest common multiple. So 2 to the power 4, this is 3 to the power 3 and 7 to the power 1, obviously, right? सारे डिफरेंट लिख लेने हैं, सारे डिफरेंट मल्टीपल्स जितने भी हैं, और फिर उनकी हाईएस्ट पावर लिख देनी है, राइट चिल्ड्रन? So let's find out LCM. It will be 3024. Now let's check HCF into LCM. 6 into 3024. 6 into 3024 is 18144. Let's check. Are we getting the numbers 336 into 54 also as the same thing, 18144? Yes, we are. So again, it verifies the fact that LCF into HCF of two numbers is equal to product of the numbers. So that is how we will do question number 2. Now, obviously the second part you can do it on your own. Let's move on to the third part and let's verify कि ये जो formula है क्या ये 3 variables के लिए 3 numbers के लिए valid होता है या नहीं. Let's do, and I will verify this formula for 3 numbers. Is it valid? Let's check. Okay, I am doing third question, first part. So 12, 15 and 21. 3 numbers हैं. Let's find out the factors. So the factors of 12 is 4 3s are, so 2 2s are 2, 2 2s are 4, 3 to the power 1 into 1. Factors of this will be 5 into 3, and factors of 21 will be 7 into 3. So let's find out HCF. Sorry. Let's find out HCF of the 3 numbers first. So obviously आपको दिख ही रहा है, इसमें तो कोई confusion नहीं है. HCF is 3. Let's find out LCM. So LCM में सारे लिख लो, 2, 3, 5 and 7. और हाई 2 की पावर 2 है सबसे बड़ा, राइट? 3 तो 1 ही है, 5 भी 1 ही है, 7 ही 1 ही है, into 1 तो आएगा ही. So this is 420. So let's find out कि क्या ये valid होता है. 420 into 3. Multiply करो, 0, 3 2s are 6, 4 3s are 12. This is this, right? HCF into LCM. Let's find out 12 into 15 into 21. Let's do it. 12 into 15 करोगे तो क्या आएगा? This is 180 into 21. That is 3780. So is it valid? No, it is not valid. So that means again a fact, HCF into LCM of 3 numbers, 3 composite numbers is not equal to the product of the 3 numbers. So this formula, this method is only valid for 2 numbers. That is the point which I want you to note. Right, children? All right. Similarly, you can do the next question also. Okay. Let's do the third question and let me tell you one very important point in question number 3. 8, 9, 25. 8 के फैक्टर्स करते हैं, ऑब्वियसली पता है 2 की पावर 3 इंटू 1. 9 के फैक्टर्स करते हैं, ये भी पता है 3 की पावर 2 इंटू 1, और इसके 5 की पावर 2 इंटू 1. अगर हम HCF की बात करें चिल्ड्रन, सो HCF विल बी कॉमन, राइट? सो वो तो सिर्फ 1 ही दिख रहा है. और LCM की बात करें, सारे अलग अलग फैक्टर्स 2, 3, 5 और सबकी पावर्स, राइट? दिस इज 1800. So obviously HCF into LCM is 1800, and let's find 8 into 9 into 25. सो ये क्या आता है चेक करते हैं. 8 इंटू 9 करेंगे तो आपको पता ही है 72. 72 इंटू 25, राइट. सो चेक करिए ये 1800 आता है. तो दैट मीन्स, नाउ नोट अ वेरी वेरी इंपॉर्टेंट पॉइंट हियर. आई टोल्ड यू कि ये जो फॉर्मूला है ये वैलिड नहीं है, बट कैन आई से HCF into LCM of three numbers is equal to product of the three numbers if HCF is 1. So this formula is only valid in one condition where HCF is 1. Otherwise this formula is not valid. I hope that's the point which I want you to make a note of. All right, children. Rest everything remains the same. All right. Let's do question number 4. Now, HCF of two numbers is given to you as 9 and the two numbers are given to you as 306 and 657. And you have to find the LCM. So, ये तो हमें fact पता ही है. HCF into LCM or LCF into HCF is equal to product of the two numbers. This is a fact always. Okay. So how will we find LCM? Can I say LCM is 306 into 657 divided by 9? You know how to do the calculations. That is question number 4 for you. Now, if you want to do question number 5, check children. Here is the mistake which most of the children do. 6 to the power n. The question says check whether 6 to the power n can end with the digit 0 for any natural number n. So 6 to the power n. How can I factorize? Can I write factors of this as 2 and 3? So this is 2 to the power n into 3 to the power n. Right? Now, you should always remember for a digit to end with 0, children, we should always have 2 into 5 as factors. Right? We should always have 2 into 5 raised to power n as factors. But is it possible in this case? Right? So that it is divisible. Right? Divisible by 10. राइट. सो इसमें 2 के पावर n तो है, क्या इसमें 5 कभी आ ही नहीं सकता. सो नो, therefore 6 to the power n does not have 5 as prime factor. Therefore it cannot end with digit 0 for any natural number n. That is question number 5 for you. Please have a look at the way it is written. So you should always write this is as per. This is a very important statement. As per fundamental theorem of arithmetic. There cannot be any other factors. Right, children? So this is a very, very important statement which I want you to mention. अगर आप ये मेंशन नहीं करोगे तो पता नहीं चलेगा कि आपने इसमें कौन सा थ्योरम यूज किया है. So this is where theorem 1.2 का application will come. Okay. Now question number 6, very important one. I will do the first part for you. 7 into 11 into 13 plus 13 are composite. You have to explain. Check करो. Can I take 13 common children? तो अंदर क्या रह गया? 7 into 11 plus 1. So that is 13 into 78. तो आपको दिख ही रहे हैं, more than 2 factors हो ही गए. 13 into 78 into 1. So since this number has more than 2 factors, therefore it is composite. Okay, same way you have to do this also. You can take 5 common, right? All right, let's move to question number 7. In a circular path around a sports field, Sonia takes 18 minutes to drive one round. Okay, so the time taken by Sonia is 18 minutes. And then Ravi takes the same round in 12 minutes. The question says, suppose they both start at the same point and at the same time in the same direction. How many minutes will they meet again at the starting point? So how many minutes will they meet same? That means, what do you mean by this? How many minutes will they meet again at the same time? Don't you think I have to find the LCM of 18 and 12? That is number of minutes they will meet again. Okay, so let's find LCM. तो हमें LCM करना आता ही है. पहले 18 के प्राइम फैक्टर्स, फिर 12 के प्राइम फैक्टर्स, राइट? So 18 के प्राइम फैक्टर्स, this 2, 9, 3, 3, right? So 2 into 3 की power 2 into 1 obviously. Similarly 12 करना है to 2, 6, 2, 3. So 2 to the power 2, 3 to the power 1 into 1. Now LCM of 18 and 12 will be what? So 2, 3, 2 की पावर कितना आ जाएगा? 2 आ जाएगा, और 3 की पावर 2. चेक करिए, पहले कॉमन वाले लिख दिए और फिर उसका कॉमन क्या कह रहे हैं, सारे जो भी फैक्टर्स है वो लिख दिए और उनकी हाईएस्ट पावर लिख दी. यूनिक फैक्टर्स विद हाईएस्ट पावर. So this is answer is 36. So that means after running 30 minutes, unit is again very important children. अगर आप ये मिनट्स नहीं लिखोगे तो पता नहीं चलेगा जो LCM है आपने क्या निकाला है. सो दैट इज वाई यूनिट्स आर वेरी वेरी इंपॉर्टेंट. आई होप कि क्लियर हो गया है कि क्यों हमने LCM लिया है, क्योंकि उसने पूछा था कि आफ्टर हाउ मेनी मिनट्स विल दे मीट अगेन. तो दैट इज वाई हमें लोएस्ट कॉमन मल्टीपल निकालना है, क्योंकि दोनों ही रन कर रहे हैं. तो लीस्ट मतलब सबसे पहले वो कब मिलेंगे. सो दैट इज वाई लोएस्ट कॉमन मल्टीपल. दैट इज द ट्रिक ऑफ दिस क्वेश्चन कि LCM निकालना है या HCF निकालना है. देयर इज द कंफ्यूजन विच शुड नॉट हैपन. So this is all about your second theorem, that is a fundamental theorem of arithmetic and exercise 1.2. If you have any doubt, kindly mention in the comment below. Thank you everybody.